Okay, guys, in this lesson, let's talk about using addition, subtraction, multiplication, and division when numbers are written in scientific notation. So let's start out talking about how we multiply numbers that are written in scientific notation. When we're multiplying scientific notation, we can think of it as multiplying like variables. And what I mean by that, let's say we have 6a squared times 3a to the fourth. So we're going to multiply the coefficients and get 18, and then we're going to apply the product rule to our variable and say a to the sixth. This acts the same way, where we have our coefficients, just like we had 6 and 3 up here. Here we're having 6 times 4, that gives us 24. And then this is our quote-unquote like variable. So we have a power of 10 times the power of 10, so they are like bases. So we have 10 and we add exponents. So we have 24 times 10 to the 7th. Now, remember, when we write a number in scientific notation, the coefficient has to be a number either 1 or more, but less than 10, and 24 is more than 10. So we need to make this 2.4. So we went from 24 to 2.4. Now we have this single digit that precedes the decimal. 2.4 is between 1 and 10. And because we decreased the value of our coefficient, we must balance our expression by increasing the power of 10. Instead of 10 to the 7th, we now have 10 to the 8th. Because this 24 is as though we divided by 10 and made it 2.4. So we have to increase this side. So you have to keep it balanced. So now this is in scientific notation. Let's try these together. This first one, we're just multiplying 8 times 3 to give us 24 times 10, and we're multiplying like power, so we add exponents. Negative 3 plus 7 is 4. We're going to make our adjustment here. So we're going to make this 2.4. So I went down in value on the left side, and then we must go up a value on our power of 10. So it's going to be 10 to the fifth. So if I move the decimal once, I increase my exponent once. Now we have 1.5 times 2, so 1.5. And again, remember this unit, we are not using a calculator. So of course that gives us 3. So we have 3 times 10 to the 6th power. Our number is written in scientific notation, no adjustments needed. Now we have 4.2 times 2. So 4.2 times 2. We have the decimal, we move it once. So 8.4 times 10 to the negative 9 power. Again, we have a number, our coefficient is from 1 up to 10 and not over 10, so we're good to go. Now we have 2.4 times 4. 4 times 4 is 16. 4 times 2 is 8 plus 1 is 9. And we have one decimal place. So 9.6 times 10 to the power of, here's our understood one. And so we add these together and get negative 7. Again, my coefficient is from 1 up to 10 and not over 10. No adjustments needed. Okay, pause the video. When we come back, we will go over these together. Okay, 7 times 5 gives us 35 times 10 to the power of 2. We're going to need to make an adjustment here. So we're going to decrease and move the decimal between the 3 and the 5. So I went from a 35 to 3.5. And then we need to go up on this end and increase our exponent. So I move the decimal once. I increase my exponent once. 2.5 times 3. So again, multiplying out our decimal, and we moved it once, so we get 7.5 times 10 to the power of negative 6. Everything looks good. We have 1.2 times 4. We have one decimal place, 4.8 times 10 to the power of negative 3. The coefficient is all good to go. We have 8 times 7 is 56 times 10 to the power of negative 3. Negative 5 plus 2 is negative 3. We need to adjust the 56 to make it 5.6. So I went down in value here by moving the decimal once. Therefore, I must increase the power of 10. So I'm going to go up. So it's negative 2. So don't forget we're working with negatives here. So negative 2 is increasing from negative 3. Okay, dividing numbers in scientific notation, very similar to dividing like variables. So if we have 12x to the fourth over 4x to the third, we would simply divide coefficients and get a 3, apply the quotient rule, and subtract exponents. 4 minus 3 is 1, and we can simply write it as 3x. The same goes for when we're dividing, scientific notation. You're going to divide your coefficients. You're going to apply the quotient rule. We have the same base. We subtract 5 minus 3 is 2. 3 is improper scientific notation. We're good to go. Let's try these few out together. Again, we're going to divide our coefficients. We're going to apply the quotient rule. 5 minus negative 3. Change gives me a power of 8. My my coefficient is all set. Here we have 1.2 divided by 4. We get 0.3 times 10, and we have negative 2 minus 6. Keep, change, negative 8. Okay, this time our coefficient is not more than 1 here, so we need to move our decimal to the right and make it 3. So this time I increase the coefficient. So on this end, I need to decrease the exponent, the power of 10. So to decrease, I'm going to go to negative 9. So I went from 0.3 to 3, so I went up in value in the coefficient. I need to decrease my exponent side to keep it balanced. So now we have 3.6 divided by 9. So 9 into 3.6. And we get 0.4 times 10. And we have 2 minus negative 8. Keep, change. We get an exponent of 10. We need to adjust the left side and move the decimal once to the right to make it 4 times. And then here we're going to lower the exponent to a 9. We have 2.4 divided by 1.2. Remember, this number on the outside needs to be a whole number, so we're going to move it once. So we have to also move the decimal here. So it's really 12 into 24 gives us 2. So we have 2 times 10, and it's negative 1 minus 9. Keep, change, gives us negative 10. Okay, pause the video. When we come back, we'll do these together. Okay, 6 divided by 3 is 2 times 10. Negative 2 minus 3, keep, change, gives us negative 5. Number 2, we have 1.8 divided by 3. So we're going to divide 3 into 1.8. That gives us 0.6. So it's 0.6 times 10. And then we have negative 4 minus negative 2. Keep, change, gives us negative 2. Let's make our adjustments. We need a number that's 1 or larger but less than 10. So we are going to increase this to a 6. We move the decimal to the right once. So we increase our exponent, or we decrease our exponent once. So if I increase the left side, I must decrease the right side and go to negative 3. we have 3.2 divided by 4. 4 divided into 3.2 gives us 0.8. So 0.8 times 10 to the 7 minus -3, keep, change, gives me an exponent of 10. Now we have 3.6 divided by 1.2. Move our decimal once here, move our decimal once here. So it's really 12 and a 36, which gives us 3. So I have 3 times 10, and 5 minus 5 is 0. So we could just say 3, because this is 3 times. Remember, anything raised to 0 is 1. Okay, now let's take a look at adding and subtracting numbers in scientific notation. So this is different than multiplying and dividing, just like combining like terms is different. So when you combine like terms, if I have 7x plus 3x, I can combine these because they have the exact same variable. So this gives us 10x. It's not 10x squared, it's just 10x. If I have 7 x's and I add 3 more x's, I still have just x's, but I have 10 altogether. So if we had 7x plus 3y, we could not combine those. Those cannot be combined. They are not like terms. Same goes for when we are adding or subtracting numbers that are written in scientific notation. So this example, we see that our power of 10 is the exact same, 10 to the third times 10 to the third. So this we can combine easily. So we add the coefficients, 6 plus 4 is 10, times the like power, 10 to the third. Let's take a look at this example, and we notice this is 10 to the third plus 10 to the second. Those are not alike, so we need to make an adjustment. We can either make this exponent a 2, or we can make this exponent a 3. You just play around with it and decide which way you want to adjust. So I'm just going to go ahead and adjust and make this an exponent of 2. So if I decrease this exponent by 1, I must increase this coefficient by moving the decimal once. So I am going to rewrite this scientific notation into an equivalent expression. So it's like I took a 10 from here and put it with a 6. So that's really what was going on. Plus, we have 4 times 10 squared. So now we can add the coefficients, just like you do on like variables, and we get 64 times 10 squared. So if I add powers of 10 squared, I get powers of 10 squared. Now, before we move on, we need to make sure that this coefficient is between 1 and up to 10, but not greater than 10. So we're going to have to adjust it here. So I'm going to go from 64 to 6.4 times. So I went down in value. So I must go up in value with my power. So it's going to be 10 to the third power. Let's do these two together. I notice that my powers are not the same. I'm going to adjust this and make it 70 times 10 to the fourth plus the 5 times 10 to the fourth. And I'm going to add the 70 and the 5 to get 75 times 10 to the fourth. We're going to make our adjustment. We're going to go down in value to make it 7.5. So I need to go up in value to make this a 10 to the fifth power. Okay, this time I'm going to adjust this power to a power of 4. So I went down 2 exponents, 2 powers of 10. So I'm going to move my decimal 2 times and increase it to 300. So 3 times 10 to the 6th and 300 times 10 to the 4th are the same thing. I'm just making equivalent expressions. So I'm going to have 308 times 10 to the 4th. Making my adjustments, I'm going to go down by moving the decimal twice. So I have to increase my exponent twice to a 10 to the 6th. Okay, a couple of more. So now we're having some negative exponents. So let's pay attention here. And again, you can adjust either way. So I am going to make this number here into a -5. So I'm going to increase this. Actually, I'm going to just make this a -6. So I'm going to increase. So if I make this a -6, I have to decrease this part. No, the way around. Oops, let's just start over. Take two. Take two, guys, take two. Okay, so again, it doesn't matter which one. Let's just pick. Let's make this like I've started out with as a -5. So I'm going to keep this side as is. We're going to make adjustments. I'm going to make this 10 to the -5. So going from -6 to -5 is increasing. So if I increase here, I have to decrease here, and I'm going to make this 0.3. And now when I combine these, I have 9 plus 0.3, which is 9.3, times 10 to the -5th. Now, if you would have done it the way we were about to do it, you still would get the right answer. You would just have to make an adjustment probably at the end to make sure this coefficient is written in proper notation. Okay, here we go. Let's change this -4 to a -2. So from a -4 to a -2 is increasing. So I must decrease this by moving the decimal twice. So I went up here in value. So I'm going to go down in value here, and I'm going to move it twice. So I'm going to add my coefficients and get 4.084 times 10 to the -2. And the coefficient looks good. Okay, let's subtract a couple of these. Okay, same idea. I'm going to make this 10 to the 7th. Let's make it a 10 to the 6th. So if I make this a 6, I went down here, so I need to go up here and make it a 50. Minus 8 times 10 to the 6th. So we have 50 minus 8, so that gives us 42 times 10 to the 6th. So I need to make my adjustment here. So I'm going to go down on the left side and up on the right side. Okay, let's make this adjustment. So if we make this a -4, that's decreasing, and so we increase our coefficient. So I'm going to increase to a 76. I'm going to decrease with the -4. And we have 76 minus 4, that is 72, times 10 to the -4, adjust, 7.2, I went down, times 10, I'm going to go up in value, so that's a -3. Okay, pause the video. When we come back, we'll go over these together. Okay, I'm going to make this exponent a 2. So I am going down in value here. So I need to go up in value here. I went down by 2 powers of 10. So I have to move my decimal twice. So we're going to make that 700. So again, these two expressions are equivalent. They represent the same value. We're going to subtract 700 minus 4. So that's 796 times 10 to the power 2. We need to go down in value by moving the decimal twice. So we will go up by adjusting our exponent, going up twice. So 6.96 times 10 to the 4th. Here we have negative exponents. So if I make this go down to -3, so I'm going to go down here, I'm going to go up on the coefficient. So we're going to have this as 80 times 10 to the -3 plus 6 times 10 to the -3. So we're going to add 80 plus 6 to get 86 and bring over our common power of 10 to the -3. We're going to make adjustments, go down 8.6. We're going to go up. Again, be very careful with negatives. Going up 1 is going to bring us to a -2. 2.4 times 10 to the -5. So we could make this and go down here and then go up on this side. So if we go up here, that makes it 24. If we go down here, that makes it -6, which matches our -6 here. We're going to add 24 plus 4 is 28 times 10 to the -6. We're going to make our adjustment so our coefficient is in proper notation. So I went down on this side. I go up here. Again, I have to stop and think myself with these negatives and going switching up and down. Okay, here we are subtracting. So let's go down here and make this -4, and then we'll increase the 9 to a 90. So we're just taking a 10 here and multiplying it by 9 to get 90. So we have 1 less 10. That's really what's going on, guys. 90 minus 7 gives us 83 times 10 to the -4. Make our adjustments down and then up. So 8.3 times 10 to the -3.